right, this first little guy, you're probably like, I thought we already knew how to do this. Well, I have taught it, and I think not everybody knows how to do it. So we're going to do this one together again, and I want to explain it one more time. We're looking for the limit of this whole thing here, and we've got two parts that you kind of have to be aware of. They tell you what f of x is. And again, let me just say off to the side, taking this one step at a time. If this says f at -2, Emily, what do I do with the -2? Plug in -2 everywhere there's an x. Presser, what if this said f at a squared? With a squared though, right? Bryce, what if this says f at a plus h? Plug a plus h in everywhere you see an x. You guys see where I'm headed here? The function has x at x plus h, take x plus h, plug it in everywhere you see an x. That's what we have here. So we have the limit as h approaches 0. We're all writing this down. For just the yellow part is all we're concerned with now. So we're going to take this equation. Everywhere I see x plus h, I'm going to plug it in for those x's. So I have 3 times, not x squared, but x plus h, the quantity squared, minus 4 times, not x, but x plus h. And that's the yellow piece. But we're not finished. We still have to deal with the pink one. So we have minus f at x. Take the x, put it everywhere you see an x, which is just what it is. So 3x squared minus 4x. Did I write that correctly? Thank you. Marina caught it. Parentheses, because you're subtracting the entire function. So there's the pink part. And the whole thing is over h. Questions with how I got that written down? All right, you guys simplify this entire piece, and let's see if we can all come up with the same stuff. Oops, minus. This is an H. When you finish, look up, our answers should match. The very first step kind of baffles some kids. Don't forget you have to FOIL that x plus h quantity squared. It's not x squared h squared. So that's where I got that stuff in pink. Distribute the 3's. Cross out the stuff that cancels out. Take an h out of everybody. You're left with this. If I plug in 0 now, it's perfectly legal because it doesn't make anything undefined, so it's fine. So we wind up with 6x minus 4. Any questions? Yes, sir. Brandon.
Why did you not distribute the negative to the 3?
I did. Minus negative is a plus. Yep. Good question. Dalton, did you have a question, hon? Good question. I wanted to see if I could plug in 0, and you can. Yep. 3 times 0 is 0. Yep. Anybody else? Okay. So this next piece is talking about continuity. And you already know these 3, but you've never really written them down mathematically. And they're actually on the board here behind Ashley, if you want to see them. The limit, as x approaches any number, we call it c, where the function has to exist. The limit at that place has to exist. That's going to help us determine if it's continuous. Alex, let me write this down. Also, the function at that point has to exist. And the third thing is that the limit and the value have to be the same. The limit as we approach the number for the function and the function at that value have to match. If those three things are true, then it is a continuous function. And you guys are really good at looking at graphs and telling me if it's continuous or not, but you may not be so good if you're not given the graph. So this will help you kind of get there. All right, let me give you an example and a non-example. Here's your example. So if I asked you, and this is a really bad picture, so don't judge too harshly. Sorry. The limit as we approach 2. Well, as we're approaching 2, it looks like it's, I don't know, almost at 1, right? So the limit does exist. Number 2, does the function at that point exist? If I go to 2, yes, there is a value. Then it's at 1. Then we have to see, are both of those answers the same? Well, as we're approaching it, it's 1, and the value there is 1, so yes, it's continuous. A non-example would be, same kind of deal. Only it looks like this. So this time, the limit as you approach 2, it's still 1, but the value of the function right at 2 is negative 2. Those two answers did not match, so it's not continuous. So even though the limit exists and the value itself exists, it doesn't make it continuous. Those two numbers have to match up, and that's going to come up here later in the notes. Questions? Flip the page. There's two kinds of discontinuities. There's removable and non-removable. Removable just means that, removable. It means that if you've got two binomials, one on top and one on bottom that match, and you cancel them out, you are removing the discontinuity. That's why it's called removable. What kind of discontinuity is that when that happens? It's a hole, right? What kind of discontinuity is that? What's it called? Point. So point discontinuity would do that. Point discontinuity, or if there's a hole, it's a removable discontinuity. And I'm just telling you this because your book starts to use vocabulary like this, so it's just good for you to know. Also, it shows up on the AP test, so you kind of need to know what they're talking about. If they say removable, they mean is there a hole? Okay? Non-removable, Well, what kind of discontinuities do we have? Jump. And if it's jump discontinuity, what kind of function does it have to be? Piecewise. Now keep in mind, just because it's a piecewise doesn't mean that there's a discontinuity. Sometimes, and you're going to see that in a minute, they are continuous, occasionally. But there could be jump discontinuity, which only comes from a piecewise graph, or piecewise function. And what's the other kind? Infinite. Thank you for not saying continuous. Infinite discontinuity, what does that indicate?
Asymptote.
An asymptote. Specifically a vertical asymptote, by the way. So they've got examples there, kind of shown. Questions? Everybody good? The non-removable. So they kind of divide up right here. The only kind that is removable is the point, or if there's a hole. The other ones are non-removable. They're just there. So let's look down here at the left and right hand limits. Excuse me. They want to know the limit for this function as x is approaching 8 from the right. What do we do? Plug it in. How come we're allowed to plug it in? It doesn't make it undefined, so it's fine. So if we plug in 8, we get 1/16. And 1/16 happens to be the limit from both the right and the left, so it still works for the answer. Does that make sense to everybody? The next one. We're approaching -8 from the right. Can you plug -8 in there?
No.
This time we can't. Alex, how come? Right, we can't have the bottom be a 0. So we have got a problem. And here's the other problem. This is a quiz, and you don't have a calculator, and you're allowed to have one. So, get yourself a little T-chart going on here. And let me ask you a question. We already know that we can't plug -8 in because there's, going to be a problem there. What does that produce on the graph? A hole or an asymptote? An asymptote, because we're not canceling anything out. It's a non-removable discontinuity. It produces an asymptote. Now, I don't really know what this graph looks like, and maybe you don't know, maybe you don't care, but here's 8. Whoops, -8. Nope, 8. Nope, -8. Goodness gracious, what's wrong with me? Here's -8. Here's our asymptote. We know that graph, as it approaches it from the right, it's got two choices. It's either going to go up to infinity for forever or down toward infinity for forever, right? So if you were going to guess, which I don't condone guessing, but if you were, you've kind of got a 50-50 shot. You know it's going to do one or the other. And you can actually figure out which one it's going to do. What's a number that's, okay, we're coming from the right. So what's a number that would be to the right of this -8? -7 isn't snuggled up close enough, probably. How about -7.999? That would get us there. Remember, a limit, you want to get as close as you can. So -7 may not cut it. May not be close enough. So -7.999. And remember, you don't have a calculator, but you can still do this. Now, this is a number I'm allowed to plug in because it doesn't make it undefined. So I have 1 over -7.999 plus 8. So I have 1 over, what's on the bottom? 0.001, right? 1 divided by a teeny tiny number produces a positive or negative? A positive, and is it a really huge number or a really tiny number? Huge number equals a big positive number. Big positive number. If it's producing a big positive number, am I headed to positive infinity or negative? Positive infinity is your answer. And you did that without a calculator. Okay? Next page. They've got a piecewise function here, it looks like. It may or may not be continuous. We're not sure at this point. And they don't give us a graph, but they want us to approach 3 from the left-hand side. 3 from the left. Well, let's look at our restrictions here, and that's going to help us. This says where x is less than or equal to 3. So this piece of the graph only exists on the left-hand side of 3. We're coming from the left. So it sounds like we're pretty much only concerned with this guy right now. Can I plug 3 into that? Yeah, it doesn't make it undefined. What's 3 plus 2? So 5 over 2 is 5 halves, or 2.5. So it is approaching 5 over 2. The limit is we approach 3 from the right. Well, this guy doesn't work anymore because we only graph on the left-hand side of 3. This one we graph on the right-hand side of 3, and we're approaching it from the right. Can I plug 3 into this one? Even though this doesn't have an equals to? Thank you. It's a limit. We're wanting to know what is it approaching, not what is it exactly. So it's fine. Take a 3, plug it in. 12 minus 6 is 6 divided by 3, which is 2. Why not, Brandon? Why is it not continuous? Right. We're approaching 2 different values. From the left, we're coming to 2.5. From the right, we're coming into 2. Those two aren't going to match up, so it is not continuous at 3, which is kind of where we're headed on this. So we say not continuous. At x equals 3. What kind of continuity is that? Is it removable or non-removable? Non-removable, because it's not a whole. You might want to just add that on there just for extra. It also asks us, what is the function right at 3? Which one do I plug it into? This one has the equal to, so it can be exactly 3. Take 3, plug it in, we get 5 halves.
Why is it referred to as removable and not removable?
Because removable, you can cancel them out, you can take it out.
You can take it out and grab it without it.
Right, exactly. And just so you know, for you visual people, if you did want to graph this, you could. Like if you were on a quiz and you had to do this and you were panicking, you weren't sure what to do, you can graph this. This little guy right here looks scary, but if you think about it, this is really 1x over 2, so that's a half x, plus 2 over 2 is 1. You know how to graph that. 1/2 x plus 1. Here's your 1. Rise 1, run 2, rise 1, run 2. So here's your line. And it's only true left of 3. So there's that part. Other guy, 12 divided by 3 is 4. Negative 2x, or negative 2/3 x goes in the front. You know what that looks like? It's a line. And y-intercept is going to be up here somewhere. It's going to be down, and I happen to know that it looks like this. So that's what it looks like. Alrighty? Any questions on anything we've done so far? Next piece. Greatest integer function is going to show up, but I want you to be ready for it. Let's talk real quickly about what greatest integer function means. What does integer mean?
Whole number.
Positive or negative whole number, right? So, based on what you see here, I want to know what is f at 2.4. What's the biggest integer you have? 2. So the answer is 2. What is f at 2.99? Still 2. The biggest integer you've approached is 2. Now here's one for you, and don't say the answer out loud. What is the function at negative 5.1? Think about it. Talk with your neighbor, see if they agree. All right, how many of you say the answer is negative 6? -5. -4. Well, at least you guys all got that part right. It's not -4. Think about this. Number line. 1, 2, 3. Here's -4, -5, -6, -7, so on. -5.1 is right here. Which one is greater? -6 or -5? -5 is greater. But we're coming in from the way that we read. What's the greatest integer you've approached so far? -6. You have not reached -5 yet. So the answer would be -6. So be really careful on those negatives. You got to think that through. Next page. The limit for that function is we approach 4 from the left. 4 from the left. So here's 4. What number is snuggled up real close to 4 on the left-hand side of it? 3.999. Now, why can't I just use a 3? What happens in a step function right at the whole number? It jumps. So you don't dare plug in that whole number because it will not help you. You want to plug in the number that's snuggled up right next to the other guy. Jacob, wake up, dear. So we put in a 3.9999. What's the greatest integer for 3.999? 3. It's the greatest integer you have so far. You've got a 3. What's 5 times 3? -7? Just curious. What if I put in a 3.1 here? It's the same answer because the greatest integer is still 3, so you still come up with 8. So what's the limit as we're approaching it from the left? From the left, it's at 8. Will the answer be the same as we're coming from the right? For a step function, it won't. It'll be 9. Okay? Questions on that? Last little bit. Find the x values where f is not x values where f is not continuous. Which discontinuities are removable? Let's talk about the first function. Is there anything x can't be? Can't be 0, so it is discontinuous at x equals 0. Is it a removable or non-removable discontinuity? Non-removable. Does it create a hole? No, so it's non-removable. It's a vertical asymptote. So non-removable. Next one. What can x not be? Anything else?
Negative.
What we factor? Looks like x can't be positive or -3. So it's discontinuous. At x equals 3 and -3. Removable or non-removable? One of each. Which one's removable? The whole occurs at which value? 3. So this one's removable. Because that's the one that creates the hole. Other guy is non-removable because what does it create? There you go. That's the question that kind of got some of you guys on a couple quizzes ago. I was asking about discontinuities. There were 2 of them. One was point discontinuity. One was infinite discontinuity. A lot of you guys just gave me one answer. Last one. You guys did that one by yourself. It's a little bit tricky. Heard him. Last one. Work on it. Does this one feel a little bit different? Let me ask you this. For this one right here, just x, is it continuous or discontinuous? Continuous. X can be anything, right? All right, how about x squared? Can x be anything? Yes. Do those two facts alone make the whole thing continuous? No, because it's a piecewise function. So what kind of continuity are we doing to be aware of? There could be jump. Here's how you know, because it shows up on your assignment. You ready? Take the 1, because that's where we left off, and plug it in for x. We picked up again at 1, plug it in for x, and let's see what we get. If you plug in 1, you get 1. You plug in 1, you get 1. If those two match, it's continuous. Here's what the graph looks like. You've got a line, and then it picks up and it's a parabola. They join forces right there. So it's continuous. Alrighty? Alright, there's your assignment. Let y'all get started. I'm going to pass back your quizzes so you can see kind of what you missed and all that mess.